And in part 2, if we were to analyze what is being described, what we can see now is a GP. And for this GP, it's going to have a first term as 256, and the common ratio is actually 8/9. And if I were to say Sn as the sum of this GP, what this question says is, what if the total depth that is drilled is going to exceed 99% of the theoretical maximum of the total depth? What is the theoretical maximum of total depth? That is the sum of this GP to infinity. And it is possible because R is 8/9. It is between -1 and 1, which means that according to what the question wants is for the total depth to be more than 99% of the theoretical maximum. Applying the sum of GP formula, I'm going to make use of A1 minus R to the power of n divided by 1 minus R. And this is supposed to be bigger than 0.99 of A/1 minus R. So it is going to be equal to 256 of 1 minus 8/9 to the power of n divided by 1 minus 8/9. This must be bigger than 0.99 of 256 divided by 1 minus 8/9. This is positive, and they are exactly the same, so I'm going to cancel this away, and it's not going to affect the inequality sign. So 1 minus 8/9 to the power of n is going to be bigger than 0.99. I'm going to solve for the range of values for n, and since n is an integer value, I'm going to make use of the table from my graphing calculator. Making use of the table, if I were to generate that table, one side is going to be n, the other side is going to be 1 minus 8/9 to the power of n. Scrolling down the table, when it is at 39, it is 0.98988. When it is at 40, it is 0.99101, and it is bigger than 0.99. And when it is 41, the trend continues. This is 0.99201. That's why we can see that n is bigger or equal to 40. And that is also why it is going to take up to 40 days to exceed 99% of the theoretical maximum total depth.